Okay, now it's recording.
Excellent. So first question before we get into updates is, Paul, given your recent change in status, I assume that you'll also at some point be stepping out of the dockyard Slack and then getting in as a guest like Brian's been doing, or are you gonna be sticking with what you've got?
Oh, I won't be in the dockyard Slack at all, but I'll be in the Elixir one. So, our Lumen channel that we have going.
Gotcha.
So that's where all my activity will be. And then I'll be still coming to the stand-ups.
That's what I figured. Just wanted to make sure. So who wants to start with updates?
I can go. So I've got some more progress made here. I actually pushed up all the changes across the different projects that we have right now, LVM, EIR, and my own branch with all the cogen work, just to start thinking about what the merge is going to look like. Excuse me. I did run into some issues with EIR just this morning, actually trying to get a module to compile some of the, those like valueless things, Hans, that you said weren't going to be in the IR. I'm coming across them in some places. And
so in which cases?
I can try and see here.
So there are parts where value lists are argument to operations, but that's
right. But that was supposed to be like at the higher level, right? So even after lowering that can happen.
So for high level stuff, value lists are allowed to be used as values, where they're allowed to be passed around and stuff to
right.
their blocks and that kind of stuff. At the low level where you're at, it's not going to be passed around, but some operations take value lists as arguments if they require multiple arguments. So say if it takes multiple destination blocks, then it might take a value list instead of having them just unpacked. It's just like one argument that's a value list that has all of the blocks. So it shouldn't. It's just like a semantic that should.
Yeah, so I mean there are value lists that are arguments to say like the match, for example, like getting the arguments for the branches and those.
Yeah.
The place where I saw it, I guess, was one that I wasn't expecting into. So it was lowering a prim op. Let me see if I can find where this was in here. I swear to God, Kat, if you keep this up, I'm gonna kill you. I'm gonna do it. Interesting. Okay, yeah, so there are several places in the IR dump, just the textual form, where this particular value that my code bombed out on is rendered as an empty value list. And there's like several of them in a row. I'm not sure if those are placeholder. They kind of almost look like it. So there's like a value list with actual values in it for a match block, and then two empty value lists with the same value ID. But let's see, which block was this specifically blowing up in? 178. So yeah, I guess let's see. It's back up. I don't think that's the right one. It must be though. Yeah, these are all block arguments. So it's like calculating the destination blocks. Yeah, I think it's just those empty value lists. And I guess I would have to dump a little bit more metadata than I have in my debugging output right now to know if they're actually empty. but they render as empty in the text.
What are they passed to? Do you remember?
In every single case, these are prefacing a match operation.
Okay, yeah. So then, for the match leaves that are that don't have any arguments, they just get an empty value list. And then you have the ones that get one. A single value is semantically exactly the same as a value list with one entry. So those two are the exact same thing. There's no difference between them. So for ones that only take one, they take a value list of one, but it's only a value because they're identical. And then if there's any leaves that take more than one, then they take a value list of 2 or 3 or whatever. But I don't think there's any that do that.
This one failed when lowering a primop though, and a match is not a primop. What? I mean, I guess it's reusing the same value for multiple things, but I can't find where this particular value is being used in front of something that's not a match.
I don't believe there's any primops that should take value lists. I don't think that's...
Yeah, I think that's why my code here is blowing up, because
yeah, so there might be something wrong there.
Yeah, it's probably just a bug with how I'm resolving which value maps to, like, through the arguments, you know, for things that I have to implicitly lift into explicit arguments.
Yeah.
But I'll have to dump a little bit more information out. Anyways, that's really the only thing. Other than that, pretty much this whole module is lowered. You know, I have that little test module that has a bunch of different things in it that I'm using to test compilation. So once I get past this, I think that the entire module will be done.
Nice.
The second stage of this, though, is something I started looking at yesterday and today, and that's how, like, linking this up to the runtime. So some of that work I've already laid the groundwork for. But the bigger questions are really around two things, and I'm still trying to, I guess, decide what the best way is to do it. So first one is around exception handling and how we want to deal with that. So the WebAssembly exception proposal has made it far enough that I guess that there's support in Chrome, at least. I don't know about Firefox. The WebAssembly backend also has support for it. I'm talking native exceptions, not the in script and garbage exceptions. Ones that we can actually use. And they more or less map to like C++ ABI exceptions, which is nice in one way in that we can lower exceptions in a way that's more or less uniform across the various platforms we want to support. The downside is that they don't map particularly well to this kind of language where recursion is heavily used, because they invoke calls that you have to use prevent tail call optimization in a lot of cases. So traditional unwinding doesn't work great for us, I don't think. I would have to probably do some testing to see for sure, but the alternative is in MLIR, when I lower calls, to lower all calls implicitly with sort of a multi-return semantic where every call implicitly has an error value that's true or false, along with the result of the call, or no result if it's a void function. And then what we do is anytime an exception, like we'd have to maintain in the process side our own sort of like exception handler stack. But anytime an exception is thrown, we just do our own kind of unwinding checking that exception stack on our way back up. And we may not even need the handler stack if the code can be lowered in such a way that the control flow just works. But that'll be something that you and I will have to look at, Hans, because I'm not 100% sure that that's really going to work as well as I would think. The point is, it's not as simple on the surface as it would appear, because we have to be very mindful of tail call optimization. Anything we do around exceptions that burns us there basically renders programs.
Well, if we do the method with two return values, then a tail call a tail call optimization in Erlang can only be done if there's not an exception handler. Like if there's an exception handler and a tail call within that, then tail call optimization, I don't think that's going to be performed then.
Right. Yeah. So any place where there is a try can't like that frame can't be tail called out.
So then it should be fine to just do
child calls can. So those like anything below that doesn't throw exceptions or doesn't try and catch them can be flattened using TCO, but that one stack frame for sure would not.
That's fine. That's how actual Erlang works. That's why you always have to
I
do
know
the error
that's
kernel.
not what I'm talking about at all. I'm talking about the fact that any sort of anytime you're calling a function, if you use invoke because you don't know whether the other function actually throws or not, that implicitly prevents tail call optimization, like period. So the only way to fix that is if you do interprocedural optimization or analysis that says, okay, well, I know that I'm calling this function. It doesn't have any landing pads or anything in there. It doesn't throw exception, so I can go ahead and safely lower this as a call rather than an invoke. And so that is probably the better way to go. The thing I'm afraid of is finding out that it does not optimize as well as we would want it to. We end up in a situation where recursion is broken. The naive approach of doing like the return code based thing is something we already kind of have to do, at least in some places, due to the fact that we're going to have to communicate across the FFI barrier to any of our code, our runtime code that calls in or expects to receive a result from functions called in the generated code. Technically, if we follow the C++ ABI though for exceptions, we can actually catch exceptions thrown from a process in Rust because their exceptions are modeled on top of the C++ ABI. But that's like not a stable ABI. But we could bank on it if we wanted to.
I mean,
anyways.
Once we get down to the level of the BIFs, there's only 3 of them that don't have an option of, right now anyway, and like 100 plus that have exceptions. So they mostly have a potential to throw an exception because a lot of them can bad arg.
Yeah, exactly. Like pretty much anything that we can feed something into can bad arg for one reason or another.
But in most actual Erlang code, we also know that a lot of times, yeah, there may be a BIF way down there, but it may just kill the process. So really, we only need you could tail call everything in between because the actual catch is the process exits part of the runtime. I mean, the way I wrote by hand, it always has to check, so it's kind of annoying. And there's no jumping up multiple stacks. It just freezes it at the exception and looks at the stack frame because it has to track it manually.
Yeah, I mean, if we had continuations, this would be like not an issue at all because we would just jump out to where we need to go and just store the last continuation at the top of the stack. But we don't have that right now. We could support that eventually, which is really the intent. WebAssembly is eventually going to get enough primitives in place for like their exception stuff that we can actually implement continuations on top of that. And then on every other platform, we have set jump and long jump or some other primitives that allow us to accomplish the same thing, which makes all of this vastly easier.
Did you see on the proposal for the in-person at Google next month is actually they're going to cover stack switching primitives maybe?
I did see that, yeah. Andreas seems like he's been spending some time thinking about it finally. The only problem is I don't know when that's going to actually land.
Yeah,
they have been doing a lot more work on the exceptions repo as of late. So I think they've been trying to move that along because it's getting to the point now where it's pretty important. But yeah, I don't think we can really bank on that in the near term. So really what I'm looking for is a solution that's like not gonna put us in a corner, but works well enough for the near term for the code that we're trying to generate, which is why I'm thinking that the sort of the return code based way of doing the lowering would serve us better because it doesn't really require any special code. It generates a lot more code. Well, maybe, I don't know. Probably shakes out to be the same because the exception stuff in LLVM is pretty noisy, but and then once we've got better primitives in WebAssembly, then we can explore trying to actually make use of those instead, which would be really my preference because we'd have richer tools to work with there. But so exceptions is one part of it. We just have to kind of figure out what we think is going to work best in that near term, sort of like next 6 months kind of window. Because I think about 6 months out is likely where like anything that's going to be happening on the exceptions front would start making into the browsers. And then the other major part that I was looking at, see, there's installation stuff, which I took care of. Here's the exceptions piece. Oh my God, did my brain just shut off? Shit.
Don't worry, it's not like it's being recorded or anything.
Went too deep down the rabbit hole on that, and then I lost my train of thought that started the whole thing. All right, well, let's just start back up at the top, I guess. So that was one of the things that I needed to take a look at for integrating with the runtime. Yeah, that's the other part. The second piece is how I was just looking at like how I would hook into the runtime with like minimum having to change anything. But that's harder than it looks because a lot of like all this, the way the code stuff works, the stack frame management stuff, like none of that really applies. But it seems like that's maybe fairly interwoven with how some of that scheduler stuff works. And so what we're going to need to probably do is either have like keep the existing scheduler that's there for like the interpreter stuff, because that works. But then have a second scheduler that's sort of our interface from the native side. And that's the scheduler we use when we're compiling with the CodeGen backend.
I mean, for the interpreter, I don't even use the stack. I only like, if I need to return to the scheduler, I create one stack frame. That's like the last thing. I just do continuations in there. So it's not like.
Right. Basically, there's almost virtually no connection between how the interpreter works and how the CodeGen side works.
Yeah, but I'm just saying there's no use in preserving any of the stack stuff to keep that functional, if that makes sense.
Right. Sure. Yeah. Okay. Like we can get rid of that if we're not actually using it. That sounds
Yeah.
fine. But I know just from looking at the scheduler that some of that is being used as sort of the basis for how it kicks off, like starting a process. And then I guess I would like to probably spend some time with Luke to get a better grasp of like how the scheduler is designed to work and how we can either modify it to fit how it's going to need to work, or find a way to basically integrate the two sides together smoothly. One of the things is that a lot of the metadata for when control is in the like generated codes side is that I'm going to want a lot of that data to be in thread locals. So an example is we'll need the current process as a thread local that can be mutated from either side. So when we return control back to the scheduler and the scheduler scheduling another process, I'm talking in the context of a single thread here, it sets that process pointer to itself, to the process struct pointer for the process that is being scheduled. And then anytime the generated code is calling into the runtime to do allocations on the stack or heap allocations, and basically any of those runtime functions where it needs to interop with the process struct, it uses that pointer to get a reference to it. Because this is all thread local happening within a single thread of execution, that's all safe from a safety perspective, but that's really the only way to make that even reasonably performant, or even work at all, because I'm not really sure how you'd even go about doing it without that metadata living somewhere. I guess you could store it on the stack somewhere, but it really needs to be like in a reachable place from the generated code. Likewise with like the reduction count, because we're going to want to generate like function prolog that checks the current reduction count and decides whether to yield back to the scheduler at that point or not. Likewise with deciding whether or not to do garbage collection. I have a couple of, and then signaling errors back and forth. That could, or like maybe doesn't need to be a thread local, could just be a return value, but that's going to have to be something that we sort of think about, because really we need to communicate a couple different things. One is like the process returning to the scheduler because it's yielding, or is it returning to the scheduler because it failed due to an error? Is it returning because it's exiting? Like whatever the entry point is that calls into the code for that process, it's going to need to know when it gets that return value back, like what actually does this code mean? And we can just use like a integer return value for that, or use a thread local. The reason why I'm considering the thread local approach is because it also allows you to signal back the other direction. So when the scheduler returns control back to the generated code, if it sets that signal flag to say like yield or whatever, or exit, then the generated code can branch based on that at the next opportunity. So those are some things to consider. Basically, the way it's going to have to work is from the scheduler calling into a process code, and it, tacks on however many frames to do whatever it's doing. At some point, it's going to have to yield control back to the scheduler. So it's going to store a frame of it's opaque from the rest side of where it's at in terms of execution, and then return all the way back up to the scheduler where it started. And that's where you're going to get like that result code of what happened during that round of execution. And then when the scheduler is going to hand control back, it calls back into the same entry point, and then that frame gets unpacked and the code decides how to branch to where it left off. And then for calling into the runtime, it's similar, but it's a lot simpler because then it's just more like a regular function call. But there's really two different kinds of interactions there.
There's like one or two runtime functions that'll need arcs, but otherwise they just need process. Like the thread local will work, but for a couple of them they need true arcs because they have to go in like the registry where you need an arc because it needs to be stored in one place. So we can't store the literal process in the thread local because there's always a copy of, like, the arc process is in the PID to process hash that the runtime has, and then like there's the copy you're running, which is why we have arcs in the first place because of those two places. And also if you ever use the, like the add registry, you have another copy of the arc, but that's rare, but it is a thing. So if we have the thread local, unfortunately it'll still have to be an arc because there's a chance that the other process, like not in WASM where we have one thread, but like on native, in theory, someone could be messing with the, like trying to register the process if it's not already registered.
Well, the only thread local I'm talking about is a pointer to the process.
Right, but I'm saying it can't be an actual process pointer. It has to be like an arc to make it.
Well, it can be a pointer to an arc.
That's fine. That's
just
only
needs
gotcha.
to be basically pointer to an arc doesn't make a whole lot of sense, but
I do use it in some places because it saves the overhead of doing a clone arc in some places. But it is a pointer in direction. I'm not sure which one is actually cheaper. I just assume that in some places a pointer to an arc is cheaper than having to clone the arc when you don't actually care about it, but I'm not sure.
I was just thinking that we might be violating the constraints there where the reference count would be decremented, even though technically there's still a live reference, but the scheduler is holding the arc, so we don't have to worry about that. So yeah, just taking a reference to the arc or pointer to that would work, and then we just reify that into a actual concrete reference anytime we're crossing into the Rust side.
Yeah, and so for the part you said about the prologue reduction, I did the prologue for like the reduction count goes up in most cases, and except for like receives where they would fail out, I count that as not counting, but it doesn't really matter how we do it in the generated code. And then it's the process called code end of the function that is like, are you above the reduction count? Then go back to the scheduler to get the next process. Or if you're going to call the code, but you're the last stack frame, then you do the exit normal because I'm out of stack frames thing. Originally, I had that where like there was literally an exit normal call at the end, but that made the show me the Erlang stack frame thing always show there was an exit normal, which felt weird. So instead, it's just like, if you're out of code to run, like if there's no code stack frame anymore, then it's like, you get exit normal because you're out of code to run.
Right.
I don't know if you want to follow that same structure or not, but it meant it saved, with 100,000 processes running, it saved the data. Like you didn't have to have that extra stack frame for all of them that took extra space, and like, it just was space you didn't need there.
That might be an example of a place where we signaled to the scheduler that we're exiting on behalf of the process.
And then the way exceptions are handled, because I didn't have to do try catch box, I didn't have to think about the hard problem of that, is, and as an example, just I'd be okay with try and catch does not work as long as processes can exit properly when the exception. So like, as long as you don't need try catch for like in Erlang code, and you just have the scheduler knows the process died because of an exception, that would be enough to get spawn chain to work. For that, it sets the exception and then it returns what a Rust style return, because that just unwinds the stack normally. And so there is no having to do like any Erlang style stack unwinding. It just kind of freezes the stack the way it is, and nothing happens to the stack. Like it doesn't pop off all the Erlang stacks. I don't use that for the exception though. It copies the stack as it is in case you ever got to the point of unwinding it. But the exception both like stores the status as being an exception and gets that stack trace so that we can print it nice to the screen for debugging.
Hey, you guys. Brian just reminded us that we have a more limited time frame with Zoom. We've got 40 minutes. So we're down to the last 5+. So And there's no reason that you couldn't do another call, but in terms of just getting the stand-up details out of the way, looking for any other updates from anybody who's got something noteworthy. And I may start these with Luke and Hans in the future just because they've got client work, so if they have to bang early, we'll get their updates.
Not that much for me because of the client work. I'm still getting check tests to pass for having the stack frames now include the location so that we can say that it is this Erlang thing, it is this chunk of code, which on WASM is cool because it gives you actually the function index, so you can actually look up the compiled code for it. And then the file line number for when it's Rust code. And so that gives us really nice stack traces. But of course now with this new generate code, that'll be slightly different how we handle it. Because that mixes both the location, the module function, and arity. I'm getting rid of function and saying definition because it works better with anonymous functions. It's already in closure. I'm just exposing it now with how we print it. And then the location. So it'll have very nice stack traces, but of course we'll have to work with this new generated code.
I mean, the generated code's debug info will have like the Erlang module functionality as the symbol for a function. So that much will match. You know, it'll look a little bit more like a native trace, but for all intents and purposes, it's not going to be that different. Other than functions that are like not part of the actual visible module, like built-in functions and things like that. But.
Yeah, so it's been like 1.5 weeks now, and I still can't log into anything. So I've been working on Lumen still. Luke found an issue in a thing, so I've been working on that in one of the passes. So I've been working on fixing that case, and it's coming along pretty well. So just trying to get out ahead of that before we start seeing problems from trying to run actual code.
Is it like anything I'm gonna hit while I'm working on things? Okay.
Not realistically. And if you're going to hit it, then it's going to crash. It's not like it's going to produce invalid IR. So it's going to crash in the validation pass.
Oh, I was going to ask, do you have a place somewhere where you've listed out the intrinsics that you generate in the IR?
I think it's listed in the file. The place where operations and primobs are listed. I think it's listed there maybe. But I might have removed that because they got out of date.
Yeah, I'm trying to remember. Maybe I just missed it or something.
Yeah, so
I was trying to find.
I can write that out. It's mostly like the binary, or with an arbitrary amount of arguments, binary and with an arbitrary amount of arguments. Those are used in the guards, and then there is the 3 different ones for receives, which is receive start, receive wait, and receive loop, I believe. I'll write out the info for all of them so that you have.
Yeah, I just need to know what they're going to be so that I can make sure that they're modeled appropriately. The binary operators, I think you already have a representation for explicitly as premops, right? Like those aren't even intrinsics anymore. Or are they bitwise?
Oh no, I believe they're. I believe I just misremember. I moved them over to premops. Yeah.
Okay.
So you're right. Yeah.
Yeah. The only thing that aren't premops are the receive stuff right now.
Yeah. So those are intrinsics for like controlling the control flow in the receive, like state machine statement, whatever.
So that would be the only thing that I haven't bothered to add support yet for. And so if you can document what those intrinsics are, like what arguments they take, that kind of thing, then I'll make sure that I have the lowering for that. Okay. Yeah.
I'll write it in the same place where the intrinsic operation is listed in the operations file, just like as documentation.
Brian, you have anything to add to updates?
Nope, that's all. We have less than a minute of recording, so I think we should probably just end it now. I have to jump onto another call, but if people want to continue, they're welcome to.
All right. Thanks, everybody.
All right. See you later.